Hello everyone, I'm Feng Yilin from Beijing University of Post and Telecommunications. I'd like to introduce our paper, Zero-Shot Everything, Sketch-Based Image Retrieval, and in Explainable Style. This paper studies the problem of zero-shot sketch-based image retrieval, also called zero-shot SBIR. However, with two significant differentiators to prior art. Firstly, we tackle all variants of zero-shot SBIR, including intercategory, intra-category, and cross-dataset retrieval, using just one network. We call this everything. Moreover, we would really like to understand how this sketch photo matching operates. We call this explainable. Technically, a transformer-based cross-model network was proposed with three specific designs to tailor to the problem, and was achieved SOTA performance. Here's a figurative introduction of our work. The figure shows attentive regions of self and cross-attention, and the learned visual correspondence for tackling unseen cases. The biggest upside of these realizations is that just as how bag of visual words is explainable, we can directly visualize the paired correspondence to achieve a similar level of explainability. Our proposed network is a transformer-based cross-model network that sources local patches independently in each modality, establish patch-to-patch correspondence across two modalities, and computes matching scores based on putative correspondence. We exploit two losses to train our framework: a triplet loss applied on the retrieval token, and a regression loss applied on our similarity score through our kernel-based relation network. Given a query sketch and a gallery image to be matched, the convolutional tokenization is not friendly to sketches, which are typically composed of sparse strokes. So we proposed a learnable tokenizer, which can enlarge the receptive field when constructing visual tokens through hierarchical convolution, thereby better preserving structural cues from nearby regions. Then the tokens are fed into the self-attention model and interact with each other through the MSA models. Different from the vanilla VIT, we replaced the vanilla class token with the retrieval token RET to facilitate our retrieval task by computing a global representation of an image. To estimate local visual correspondence between sketch and photo tokens will result to cross-attention. The idea is to find pairwise connections between visual tokens from different modalities. In this way, sketch token embeddings are updated by the information from the photo tokens. We further introduce a cosine kernel function after the cross-attention model to explicitly measure the similarity between each pair of visual tokens. In addition, we incorporate a relation network in our framework to estimate the matching score of a particular sketch photo pair. In the end, retrieval can be performed by ranking gallery images according to their relation scores. To verify the efficacy of our model, we first conduct experiments on category-level zero-shot SBIR. We compare our method with several baselines and see that our proposed method achieves better or comparable results over other competitors, which is especially noteworthy since our method doesn't benefit from extra semantic information. We additionally compare our method with baselines on generalized zero-shot SBIR, fine-grained SBIR, and cross-dataset zero-shot SBIR experiments to verify the instance level and the generalization of the learned visual correspondence in a zero-shot setting. Results in tables show that ours consistently outperforms the others across different scenes, indicating a strong generalizability of our proposed model. Some quantitative results are illustrated in this figure. We can find that most of the top images retrieved using our approach are more faithfully resemble to the query sketches in terms of the overall object pose and shape characteristics. And the false positives given by our method are somehow reasonable, as they are superficially similar to the query. We can observe from the left figure that different heights can attend to different locations of an image, such as object foreground and different semantic parts, which are useful for fine-grained matching. And we demonstrate from the right figure that cross-model visual correspondence in the retrieved images can be roughly located given a prop query sketch, despite the objects with different poses and background. To further inspect if reliable cross-model correspondence has been discovered, we conduct sketch-to-photo synthesis by replacing sketch patches with the closest image patches. The left figure shows that the synthesized images can resemble the query sketch by stacking semantic closest patches from the retrieved natural images. The right figure reveals that some shareable local matches do exist, suggesting the learned periods of local visual correspondence could be transferred to match regions of novel objects. Meanwhile, the figure shows that how to identify the most important feature pairing responsible for a match. An ablative study is also conducted to examine the importance of each key component in our model. Moreover, we study how the keep rate of tokens in our self and cross-attention influences the final results. The results show that a lower keep rate will lead to a slight performance drop, yet a significant speed up. Finally, the employed token selection can reduce the GFLOPs and RPM significantly while still delivering the SOTA performance. In this paper, we tackled zero-shot SBL with the hope to also make it explainable. We are inspired by old vision and put forward a patch matching framework that is not only explainable but also able to tackle all zero-shot SBL settings at the same time. Specifically, we propose a transformer-based cross-model network that sources local patches independently in each modality and establishes patch-to-patch correspondence across two modalities. Besides, we advertised a kernel-based relation network to aggregate the correspondence and calculate a similarity score between each sketch photo pair. Last but not least, explainability offered as per tradition in terms of visualizing patch correspondence and by replacing all patches in a sketch with their photo correspondence. Thank you for watching. Please refer to our full paper for more details, and the source code has been released on GitHub.